Hello everybody, this is Yakov Fain with Farata Systems. We are continuing our training on Java, Introduction to Java, but this topic, or today's topic, is not exactly about Java. It's about storing the source code of your programs. So those of you who are submitting me homeworks, they will be publishing their homeworks on the version control repository, and I'll be getting them from there. In particular, we will be going to be talking about a pretty popular version control repository, which is named Git. Obviously, as I said, this is not specific to Java. You can store anything and everything in there on Git. On Git hosting site using Git version control repository. So let's start. There are different types of version control repositories. These are the places where programmers store code. If you have a team of programmers, they need to have a shared place where Mary can submit the code and then John can take the code from there and continue working on it. There are two major types of version control repositories. One of these types is called centralized file repositories. In this case, or in cases like this, we have a server, some remote server. We call it repository, and all developers, see Mary, Vlad, Ravi Kumar, all they have these local files on their machines, and they can check them into version control repository. There are popular version control repository of this type, centralized, which are SVN, CVS, SVN is also known as Subversion, TFS, Perforce, and so on. The point is that in these kind of repositories, there is one central server. God forbid this server is down or gone forever, or maybe there was a fire in the building, then we lost all the data. Of course, each of these developers will have some version, some snapshot of the current version of the system, but the whole history is gone. All previous versions are gone. Next, distributed file repositories are different. There is no concept of one and only central server where the team stores the data. Each of the developers on the team has exactly the same full copy of all versions of a particular application that we are working on, a particular project. So what it gives us? It gives us distributed version control system. So Mary and Vlad and Ravi Kumar, each of them has full version of the whole history of their code changes. What else it gives us? In many cases, you can see or read main selling point of distributed version control systems is that you can work in a disconnected mode. In many cases, they tell sometimes developers need to work on the plane. While on the plane, as you can see, Mary is sitting on the plane, and she works on the plane. What else Mary would do up in the air? I don't buy this argument about planes, but in general, the fact that you can work in a disconnected mode, the fact that you have the full version of the source control repository on your machine locally, it's nice. Why it is nice? It is nice because you can directly exchange the data between other developers or with other developers on your team. For example, Mary is working on the plane and she created some code and code doesn't work. She can say to her teammate Vlad, she would say, Vlad, can you please take a look at it? Vlad would directly connect to her instance of this repository and get the files from there. Why it's possible? Because Mary has full system, full database, everything that is needed to other people work with it. Of course, there still can be a remote repository where all developers on the team share. There could be a hosting place like GitHub, for example, where everybody will be connected to. So Mary would be pushing her changes there, and Vlad would be pulling the data from there. Or maybe Ravi Kumar, he's a QA, he doesn't have rights to push data in there or change the data, but he can pull the data from there. So the popular repositories not repositories, popular version control system which are distributed are Git, Mercurial, Bazaar. In this presentation, we're going to be working with Git, and we're going to be using for hosting, we're going to be using GitHub. Still, how do you work with Git, and what are the main terminology? What are the main terms when we work with Git? Pull and push. You probably can guess. When you do push, you submit your changes to some remote version control server. When you do pull, you get the data into your local version of repository from a remote one. So developers usually do pull and push, while QA members are usually do pull, right? When developers pushed all the changes, then QA people can do the pulls. Still, we have a term called commit. If I am making some changes on my local machine, as I said, let me repeat it, we have a local repository. If I decided that these changes are valid and must be placed or stored in the repository, I do commit. But keep in mind, commits are local. So I make my changes and they are locally committed to my local version of version control system. If I decide to share it with the rest of the world or with the rest of the team, I will push the data. So commits are local, pushes are usually remote. Pulls are from remote to local. Say, who was it? Mary. Mary landed, her plane landed. She did a great job over there while airborne, and now she's on the ground again. What she will do immediately, she will find the closest Starbucks or another cafe to get connection and push the data to the central server where the rest of the team is using, and pull the changes from the server, because Vlad was also working right on the ground. So this is how synchronization will be done between the changes, between the different pushes into a server control, version control repository. What other things that we need to know? You're going to be working locally on some directory, and directory will have a bunch of files that belong to your project. Will all changes in all files be committed and pushed to a remote repository? It's up to you. I've watched a nice video presentation done by GitHub team members, and they gave a great analogy with a supermarket. Imagine that you are in a supermarket. There's a whole bunch of produce over there on the shelf, but you have not added all of them to your shopping cart, right? So consider shopping cart as your staging area for the changes that you want to possibly commit to a repository. But the first step that you will need to do in the supermarket and in GitHub, you need to add the required resources into the staging area, into the shopping cart. So if you change 20 files on your disk, and if you will do git add on all these 20 files, then they will be considered for being committed. Otherwise, they will be ignored and will not be committed, the same way as produce is laying on the shelves and the cash register is not charging customer for those. So first you do git add. You're saying, I want to commit these particular files or products. Then you go to a cash register, right, in the supermarket, but in our world you do commit. You're saying, I am committing these changes. So the cashier will charge you, but nobody will charge you in case if you work with Git. You do local Git free of charge. So all the changes are stored now in a local database. Of course, if you want to undo, you can similar to a supermarket. You can go to a customer service and say, you know what, I don't want these eggs anymore. Can you please credit me? And you can return it. The same way with commits, you can undo. There is a command git reset. I'm giving you all these commands which you will be entering from the command line. If you are in a Windows, you will open up a command window. If you are on a Mac or maybe some Linux flavor, you can go to a terminal window and type in all these commands. Having said that, you need to know that there are graphical and user-friendly UI clients that will allow you to work with Git. But we're going to be working with command line, with the basics. Finally, we committed the changes to the local repository. Now we are ready to push data to a remote repository, right? Where the rest of the team will see my great changes. So you do git push command. So git push is the moment when the local repository will be synchronizing. No, this is wrong. When your local changes saved in the local Git repository will be promoted to the remote repository. What can happen at this time? Maybe somebody else was doing changing. Maybe somebody else even was working on the same file that you did. In that case, we're going to have a merge situation. We'll talk about it a bit later. But for now, we are pushing to a remote. If somebody wants to get the latest version of the team's work, we do pull. So you pull, git pull means get me the latest versions from the remote repository. This is it. How can you read about all that? There is plenty of documentation. For example, you can download Git from this place, gitscm.com. There is a GitHub repository, and you can get it from there, I believe. Actually, from there you can get documentation definitely on Git. Now, there are books. There's a book, Pro Git, which the author of the book kindly offers to, and their publisher, of course, they offer it for free on different languages. So this is a link for the Pro Git in English. This is a link to the Pro Git in Russian. And there are many other versions of this book in different languages. Reference manual is here, so plenty of links. And if you work on Mac, there's a chance that you already have a maybe earlier version of Git installed on your repository. So if you decide to download and install a new one, installation is pretty simple, but please make sure that you modify the path variable on your computer to have the latest version of Git up on the front. So at least you know which one you are using. And let's do a walkthrough one. And honestly, I'm not going to be doing it because I already installed it over here. You will be doing it. So you will need to download and install Git on your computer from this area, and then you will need to modify. Again, if you already have it installed, you need to modify the path variable on your machine. So this part is clear, and this part should be easy. It's very easy. Next, what else you need to do to finish configuration of Git? The minimum, the very bare minimum. You need to identify yourself. How do you want to be known in this Git repository? There is a command git config, and git config -- global. Then you enter username and you give it a name. Obviously, my name is Yakov Fain, and I'm using it. I'm not hiding under any specific other names. So, but they don't force you to enter your correct name, but it is what it is. This is how other people will see you. Next, the other thing that you need to do, you need to configure your email. In this case, I'm configuring my email, which is yakovfain@gmail.com. And what is important, if you will decide to create an account at one of the hosting places, for example, GitHub, then if you decided to give this email, yakovfain@gmail.com locally, that account that you will be creating should also be using the same email. This is an important thing, and they should match. And how do you start? How do you even start creating a new repository? There are two use cases for this. One case, you start from scratch. You never had it before. And you want to create a file, you want to put it in some directory, and you want to make this directory, you want to make it ready for use with Git. You want to create in there, technically, a Git database. So to do that, you can go open up command line, go to any directory which you believe will be your directory for the project, and in there, in the command line, you enter the command git init. We'll do it pretty soon. When you do that, Git creates an empty storage, empty database. It creates the whole infrastructure in a hidden directory right under the directory where you are. So from now on, this folder and everything that you put in there is ready to work with Git. The second case is if you already have, or somebody has a directory, somebody gave you a link to an existing repository, repository, and say somebody has said, you know what, there is this great open source project on GitHub, github.com. Go there and clone this repository. Clone is the second way how you can create a local repository on your machine based on existing one. So cloning means get the remote repository and create the exact same thing on my local disk. For example, git clone, again, this is a command that you would enter on the command line. Git clone, and then you need to specify the URL of the repository you are interested in. In this particular case, I'm saying I want to clone a repository which is known as protocol is Git, not HTTP but Git. Actually, there are different ways to do that. You can use HTTPS as well. SSH you can use. But basically, I'm saying this is the... I want you to clone the repository that is located on github.com under Yakov Fain, and this is the name of the repository. This is Yakov Fain is my user ID over there on GitHub, and I can have more than one repository there, right? So one of them apparently is called Java Training. That's why we use its name for cloning. After this command is done, say I'm in a directory temp1, for example, in the command line. If I'm there, after this command, the whole content of that repository remote will be downloaded and saved in my local directory temp1, and the database with all the changes, with all the history, with all the revisions of the files will be downloaded and exist locally. So this is exactly what I said on the previous slide. You can start version controlling any directory at any time. And the good part of it about it is, by the way, that if you have a tree of subdirectories and there is tons of different files, which and tons of different directories, subdirectories, with Git, it does not pollute the entire file structure with all these metadata. In the root directory of your project, say in temp1, it'll create a subdirectory .git, and in there the whole database will be sitting, and it'll cover all directory structures that is there. It will not put any other additional files in the subdirectory. I mean any other Git related files. And now we'll try to do this practically. Walkthrough number 2. We'll try to create a new Git repository. We'll do it locally on my machine. So on the left-hand side, I give you the steps that we would need to do, and I will do them. On the right-hand side, I created a snapshot of the temp directory, temp1 directory, actually, on my machine. I'm using Mac computer, and I did it at one point, but let's do it again from scratch. So what I want to do, I want to open up the terminal window. Where am I? I'm in the wrong place, right? So let me do cd tilde. Where am I? pwd means show me print working directory, right? I am in my root directory. My user ID on this machine is Fain11, right? So what I will do, I will be doing exactly what the steps on the left instruct you to do. So let me do that. Make directory, right? I'm making directory. Which directory I want to make? I want to make a directory called temp1. Done. Right? Now I want to get in that directory. cd temp1. What's inside? Nothing. ls minus l. Nothing. Still nothing. Now I want to prepare this directory to be ready for git. So as I said, git init. Initialized empty git repository in this folder. Correct. Correct. Let me do ls again. Nothing. Because the .git is a hidden directory, right? So ls minus a. Oh, I got it, right? Something is .git. Or you can do ls minus la for detail. It's a Unix command or Mac command as well. So now I got this directory .git. This D stands for directory, right? So what else I want to do? I want to do this tree minus a. See, it shows me the content of that directory in particular. See, it prepares the whole directory structure to be ready for storing all your data, everything. Okay, all right. Next, let's go further. Now we want to create a file, right? We want to create a file. Actually, let me go to the Finder. I want to start. I want you to see that we have this directory temp1. See, this is directory temp1, and inside there is this hidden directory git. So I can see it this way as well. So, but my point is that I want to start creating files in here in the temp1 directory, because this is my project, so to speak. The goal is to create a file in here and to push it to a remote repository on GitHub. That's my goal. Let's go back. This is my directory, right? Where am I? pwd in temp1. Good. Now let's go back to slides. So what I want to do, I want to create a very simple HTML file called index.html, and this is the content of this HTML file. It has nothing technically but the color. Background color is red, and this is how you'll see it if you open it up with any web browser. Correct? So what I will do, I will create this file, save it in temp1, open it in browser, just to prove you that it's there and it's red. And then we'll issue a couple of commands and we'll commit it to a local repository first. That's the goal of this slide. I happen to prepare this file, index with this content. What I will do, I will save it in the temp1. Save as temp1. Save. All right, let's go. I want you to see that I'm not lying to you, right? We have this file. We are in tab 1. If I will open it up, open with Google, it is red. Great, very, very good. So right click, view page source. No surprises, no surprises. Very good. So I created this file, and now what I want to do, I want to see what's going on from the Git perspective. Does it know that I'm created something new? Does it know that there is something that is ready to be committed? So I will issue these commands: git status, git add, and git commit -m with a message about the changes that I made. So let's see. Git status. I want to actually, let me do again ls over here. So you see that index.html is here, right? But I want to ask git, what's going on in here in my directory? Oh, it tells me that I have untracked files, and the file name is index.html, right? Untracked files is like in the supermarket, all those products that are laying on the shelves. They are untracked. They are not in my shopping cart yet, right? So what do I need to do? I need to issue a command git add, like you add to the shopping cart, or in our case to the staging area. When you do add, there are different options. Some people will say I always specify the names of the files that have to be added right here. Like you can do, so not gear, but git, of course. Why are you telling me that I am wrong? Git add, I could enter index.html. Being a lazy person, I will be entering git add and dot. Dot means just add all the files that I touched, created, changed, modified. Again, git status, let's see what happened. Does it know that I put my great product index.html into my shopping cart, so to speak? Yep. Now it became green. So Git version control system knows that it needs to take care of the file index.html, and it is a new file. It's not something that I had before and I modified it, but it's a new file. Very good. On the side note, I want to tell you that in some cases, if you will be just blindly saying, I want to add everything, especially when you work with some version control, some IDEs, and if IDE put their metadata files in the same folder, then you will have a situation when all these junk files, so to speak, metadata files that IDE created in your project would be going to the version control system. You don't want to do that. You don't want to have it. So there is a special file called gitignore, and in there you can enter all the files that you don't want to be considered for commits. In that case, you still can do git add and dot, but those files that meet that criteria in the file name, maybe the file extension, they won't be considered. So you can still use git add without adding all these metadata files to your repository. Of course, you can do change to the .git repository, and you can see what's in there. This is technically a database. This is a database in a special way. It's like a key value pair. They store objects which are encoded, and they represent all your changes that you made in your project. But when I go back to my working directory. Temp1 is my working directory. In my working directory, I always have one latest version of the set of files from a particular branch. We are always on the main branch. If you want to go to a different one, we will. But keep in mind, we have a database in the .git repository which has everything, and we have the current snapshot of the files which exist in the working directory, which is temp1. Back to slides. Branching. When you work with version control system, you may want to do branches. For example, we have a set of files which represent the version of the applications that we submitted to QA, quality assurance team, right? But we want to continue making changes. We don't want to touch those files, but we want to start maybe new features, implementing new features. So we want to create a branch. Or maybe I want to create a separate branch to play with some idea that I have with my file. But I don't want to screw up everybody else on my team with my great ideas. So I want to create a new branch, and this will be maybe my branch, and I will be experimenting over there. Then if I like the results of my work, I will merge my branch with another branch, maybe with the main branch. It's done pretty easy with Git. So by default, we are in the master branch. I believe you should have seen that when I did status. Yep, when I did status, as you can see over here, it told me that I am on branch master. But if I want to create a different branch, a new one, so for example, I want to create a new branch which I will call blue. Why blue, you will find out in a minute. I can do git branch blue, and it'll create a new branch for me. If I want to create a new branch and immediately switch to this branch, so I will be working with it, I can do this, git checkout -b blue. If I want to go back to master, git checkout master. If I am in the master branch and I want to merge the code in the master with the latest and greatest changes in blue branch, I can say git merge blue. So the current branch, say master, will consume all the changes from the blue branch, right? So what do we have here? What do we have here? Let's continue. Actually, the next walkthrough, in the next walkthrough, we'll do it practically. Walkthrough number 3, adding another branch, right? So let's see what branches do we have now. I'm going to be doing all these steps that you see in the walkthrough number 3. Let's see, git branch. And it doesn't show me anything. Why it doesn't show me anything? Why it's not happening? I ran a couple of commands over here to see what's going on. fsck, and tell me that head points to an unborn branch master. Apparently it's because I never did any commits yet to this branch. Let's try it. Because if you remember, I did git add, right? Git add index HTML add dot, so basically it knows that it needs to take care of the index HTML, but I never committed it. Let me do this. Git commit minus m initial commit of index HTML. All right. So basically, when you do commits, you need to enter some text explaining what are you doing. So -m in particular allows you to specify the message right here on the same command line. There are different ways of doing this, but this is the simplest one. All right. So now I did it. So let's see if it'll show me now. Yeah. Now it shows me that I am on the master branch. Fine. Okay. Next, I want to create a new branch named blue, right? So what I will do, I will git checkout -b blue. See, switch to a new branch blue. But basically, let's do again git branch. Now it tells me that I have 2 branches, blue and master, but my current branch is blue already. So what I want to do, I want to make a change, like as if I am trying to modify my one and only index HTML, as if I want to test something else. I want to change the red color to the blue color over here. Again, I am in the branch blue, and I will do blue. Save. All right. Let's see. Git status. It tells me that I have modified file index.html. Right. So it knows that there is a change. So same story. I will do git add. I will do commit, and I will switch back to master. Right. So git add, git commit -m, changing background color to blue. That's my comment. Done. Now I will switch to master. Check out master. Switch to branch master. Now ls. I'm having the one and only file index.html. What do you think? What is the color of this page? If I will open it up, what would be the color of this page? What do you think? I can guess. I will try to guess that it's still going to be red. Why? Because I'm in the branch master. So the content of this file should be red. Let me do this. cat, show me the content in index HTML. See, it is red. I told you so. If I'd be in the branch blue, the content would be blue. All right. Okay. And obviously, or sure enough, I can do a refresh over here and you'll see it as blue. Sure enough, you didn't see it as blue. Ah, sorry, as red, because I am on the master, right? The blue color is sitting in the branch blue. Okay. Next. Moving on. Next slide. Workshop number 4. I want to add another branch. Another branch. Actually, you know what? Let me do this. I want you to feel comfortable and to definitely know that in the blue branch we have a blue color. Git checkout blue. I'm switching to the blue branch, right? Let me refresh the browser. Still it's the same URL. It is blue. Now I'm working with a blue branch, but one and only working directory. But when I'm switching branches, one or the other code goes into the working directory, and it works very, very fast. Okay, go back to master with red. Next, what I want to do, I want to create one more branch. For now, we have master branch, blue branch, and I want to create a new one that is called branch 2. Branch 2. In there, I want to add some text inside the HTML file, like as if I have another version. So I'm having red empty page, blue empty page, and in the third one, I want to have a page which will be red as in master, and I want to put in there branch 2, hello from branch 2 as a header. Then I will commit the change. So we're going to have 3 branches, right? So git checkout -b branch 2. So I'm creating a switching immediately to this new branch 2, right? Now what I'm going to do, I will take this one and only file which exists in the working directory, and in there I will add this piece, hello from branch 2 header. So again, remember, we are in branch 2 now. Like this. I did that. Git status. Modified index HTML, correct. Git add. Git commit. -m. Edit title. All right, done. Commit is done. Keep in mind, everything I am doing now is local. I don't even need to be connected to the internet because everything is local, right? When I'm ready to push it to the remote server, then I will do git push, but at that time I need to be connected to the computer which has a remote service. Okie dokie, okie dokie. So where we are, I added title over here. Now I will switch back to master, and I want to show you how I will merge different versions. I have a version in master, which is a plain red page with no text. I have a version in branch 2, which is red, but with the title hello branch 2 from branch 2. And I want to merge these two while sitting in the master, right? So let's do it. So where we are, git status. Okay, I am on branch 2, right? Over here, we can see that. So git checkout master, going back to master. Done. Now what I will do, by the way, let's take a look. While we are in the master, cut index HTML, you will see that it has a red background but nothing else. The header hello from branch 2 is not here. So what I will do now, I will do merge. Git merge branch 2. Now it updated my file and it's supposed to merge it. If I don't have any conflicts, which in this case I shouldn't have, I just added a new line. I didn't modify the previous, which had the red color background, right? So if we will look at the content of the index.html file now, it's right there. So it has our header. If you want to see it in the browser, red, which was in the master, plus hello from branch 2. Everything works as expected. Next. Let's go further with slides. Workflow number 5. What if you have a conflict? Because life cannot be that rosy, or I would say as red as we have in here, but we may have conflicts sometimes. Developer A is changing the same lines as developer B, and you want to merge them. Which version will prevail, right? We don't know how to do that. We have a merging conflict, and we will need to resolve this conflict manually. We need to open up the file and see what's going on. So I will do this walkthrough number 5 just to create this conflict situation. Master branch is right there. So for now it has background color red. Remember, the blue branch has background color blue. If I will decide to merge the current branch with the blue branch, we will have a situation when these two need to be merged somehow. But which version to take, red or blue? Which background color to take? Let's see what this is a snapshot of the command line, but I will do the same thing. If I will do git merge blue now, it's supposed to take the content of the blue version and merge it with my index, which is red with header. I will get a merge conflict, right? And we'll take a look at the content of what happened when the merge conflict is. So what do we want to do? We want to are we in the master? Even we should be. Git branch. We have three branches: blue, branch 2, and master. Master is in green, which means that we are in there. So what I will do git merge blue to create a conflict between red and blue. Conflict. Merge conflict. It tells me there is a merge conflict. It tells me, I don't know, I cannot merge it automatically. I cannot. Automatic merge failed. Fix the conflicts and commit the result. Cut. Let's see what's inside. See, it highlights for you the sections that it didn't know what to do with, right? As you can see, there is one section with a red color, and there is another section with a blue color. So what do we want to do? We want to keep the section with the blue, right? So I will take this part. Actually, I need to go to the editor. Let me go to the editor. So what I will do, I know that I want this piece. I will put it here. And the rest I will just delete because I don't need it. And I don't need this. All these angle brackets, it's your identification of the places of conflict. Now I did manual merge, right? I did manual merge. So what I need to do to finish the whole thing, I need to do git add and git commit. As of now, we have unsaved changes which were merged manually. Again, git status. Both modified, right? Okay. And it changed the files. So git add, git commit -m manually merge What did I merge? I merged red and I merged master and blue, right? Merged. Okay. Oh, it's not fit. It's Git, of course. All right. So I will do this final commit. Done. Now, again, everything that we've done locally on a local database. Now it's time to finish up with the local one and do a push to a remote repository, to GitHub. But to finalize, I will show you this slide, which tells you where are the configuration files of Git. In your root directory, in your user root directory, there is a file git config. There are some changes there. And as I said, in your local project, there is a config file with changes, with specification, with the configuration options for the local project. So each project has its own config, plus there is a global config, which in particular has the your name, remember, your email address, while in the local config files you will have the reference, for example, to remote repositories. When we'll push the changes we just created to the remote server to the GitHub repository, then we're gonna then the configuration file should have the matching the name, the URL of the server where these local changes should be going if we'll be pushing data there, or if you decide to pull data into this project from somewhere. Not from somewhere, it needs to know from where. GitHub. So in this presentation I will show you a couple of things how to work with GitHub. GitHub is a public repository for Git handled projects. So far we just did everything locally. It's time to show it to the rest of the world so they can enjoy our beautiful page, which is blue and it has hello from branch 2. GitHub.com is a place for storing your projects, and they work in different modes. One mode is if you are willing to open source your project, then just create it for free, and as many users as you want can work there for free, can use it. If you want to have a private repository on their servers, then there are different charges. You have to pay monthly fee. There is another hosting service which is great for small teams, for small projects. When I say small, I mean up to 5 people. If you have a project with up to 5 people working with the source codes, with this repository, you can even have a private repository on bitbucket.org for free. And it also supports Git. Not only Git, but Git as well. So you need to decide which one you like. But we're going to be working with free, open source, because we have nothing to hide, right? Our code is not that secret. Okay. If you will be working on a real project, and if you create an organization, you can create an organization and add multiple users to that organization so many people can commit. Or you can be a private user and you create an account for yourself, but still you can add, you can allow other people to commit to your stuff. Now, how do you create a new repository on GitHub? First, of course, you need to go to github.com. Let's go there real quick. github.com. And github.com. Now, if you don't have a if you don't have a repository, if you've never been there, of course you won't see your ID. In my case, I did create it before, so I do have it there. But it's pretty simple to set it up. You need to sign up and do a couple of easy steps, and it'll create the repository for you. I believe I have a couple of slides on that subject. Yeah. So if you want to, first of all, you need to create an account for yourself. Come up with your user ID, and again, specify the user email that you're planning to use. locally. They should match. Then you will be able then log into your GitHub account when you created it. Select the tab repository over here. I also have it, but if I click on my user ID over here, see, I also have a repository. It shows me my repository, which I already have on that account on GitHub. If you create it from scratch, you won't have anything there. You will select repositories, and you're going to have to hit the button new, meaning I want to create a new one, which we'll do in a minute. So you need to create this button. I want to create a new repository. Enter the name of the project and its description. I will be creating a new repository called temp1. This is what I have locally on my disk, and this is what we want to publish over there. How do you publish your local project to GitHub? Again, I have my local repository in the directory temp1, as you saw, right? So if I will create a new repository on the GitHub, it immediately will give me a couple of commands like here. What do I need to do? Like git remote add origin, what I need to type on my command line to let the local project know where its remote repository should go. So I will do it now. I will hit new on the GitHub. As you can see, I have several projects in there, but it's beside the point. I want to create a new repository. New. What's the name of it? What's the name of the repository? Temp1. I want to create. Description. I'm not going to create any description or anything. I will create public. The directory will be public. Anybody can see it. Actually, let me put the description. This is a test project from the intro to Git by Yakov Fain. All right. Create repository. Done. See, now it shows me, it prompts me, it tells me what do I need to do locally to start to make them in sync, to make them know each other. I already did git init in my temp, right? They also suggested to create a README file. In this case, it would be README MD for Markdown. You can do just a regular text, plain text, not necessarily in Markdown format, or we are using ASCII doc format. We prefer that. But you need to do some commits, which we already did into your local directory. And then you will need to do this git remote add origin. So we are adding origin. We are saying where my master is going to go. Let me do this. I go back to my repository. Where am I? Yes, I'm in temp1, and I just copy this command over there. See this command? This one? Git remote, it's right there. I am adding this, and it saved in the configuration file this location. Now it knows where the remote server is. So now it wants me to enter the second command. Git push minus u is upstream origin master. You can copy, of course. Push minus u origin master. Done. So now all my changes were pushed to the new repository on GitHub. Actually, see, I was showing you from here, from create a new repository, but we already created the repository, so technically you should be just using these two commands, which I actually did anyway. So let me go back to my Yakov Fain account. As you can see, I have a new repository there, temp1, that was committed just now, which has index.html. This is the content of this guy. And to finalize this session, actually, let me show you real quick one comment. If I will do git pull now it knows where to get the data from. Of course, I am the only person who worked with this repository now. But if I had another team member, and that team member took the changes using git pull, took the index.html, made some changes in there, and pushed them back to GitHub, Then I would be doing git pull, and I would be seeing his changes or her changes. If I will do just git pull now, meaning I want to pull the data from there, what do we expect to see? We expect to see a message saying everything is up to date, because nobody else made any changes. Sorry. I had to say that I need to do it from origin master, and I make a typing error. Git pull origin master. I'm saying get stuff from there. It tells me, are you kidding? Everything is up to date. There is no changes there. If somebody else would be doing pushes, they would be changing there. Okay, very good. Now let me do what I want to do. So basically the procedure goes like this. If I want to make a change, I will make a change locally. I will do git add. I will do git commit. So far I'm local. Then I will do push. And after push, the change becomes available for everybody on the remote server. And actually, if after this video, if you want to go and connect to my GitHub account, you will see the STEM projects in there. Let's do this. Let me make a little change. Hello for a branch 2 to GitHub customers. I made like a change, trying to be funny. All right. So git status. Just want you to see. You don't have to do it all the time, but I keep showing you that yes, there was something modified. So what I will do, git adding, make this thing, put the stuff to the shopping cart, to the staging area, right? Git commit -m, trying to be funny. Now the changes are locally saved in the local database. Now I can do git push origin master. You know what? Let me do this. I will show you the content of the index.html on the GitHub now before pushing the button, before hitting the button enter. I want you to see that what's in there. This is what's in there. Hello for branch 2, right? Now I will go back to the command line and I will hit enter to push my changes. See, the changes were pushed in there. And let me go back and look at the content of the index.html again. See? To GitHub customers. Is this funny or what? It is. I'm not Jay Leno, of course, but Jay Leno is gone. Done? Done. What else I wanted to show you? I want to show you a couple of things, but I definitely encourage you to read about the GitHub stuff, and I want you to see how to, I want to learn how to get data from someone else. If you are in my group, if you are studying Java in my group, you're going to be pushing your homeworks in there and sending me an email saying, Yakov, the homework for units 3, 4, or 5, I don't know what, is on GitHub, and here's the URL. I am going to that URL and I do pull from there. I will do either pull or I will do clone or I will do download. Let me show you. I'm going back to my repository, and in there, I want to download stuff from there. Let me again go to temp1. Say I am not, it's not me, it's somebody else. It's someone else is looking at my beautiful repository temp1. What can they do? They can select just download zip. If they will select this option, they will get the zip file with the entire content of the project, but it won't include the Git repository. So you can use it. This is what I do with the homeworks, by the way, from the students. I don't care about Git. I don't want to have a project which is capable of being handled by Git. I just need the code. If I want to have the whole thing, I can do cloning desktop. If I do cloning desktop, the entire project will be downloaded to my local computer and saved on my local machine, including the repository, including the files that are needed by Git. So these are two options. So if you want to get somebody else's project, of course, the easiest part is clone and Git in desktop. Now, why do you want to do something like this? Because maybe you're a committer to an open source project. Maybe you want to get it from the open source repository, you play with it, maybe make some improvements, maybe fix some bugs, and then you want to put it back. You want to contribute to the community as well. You take something, you give something to them, right? So how would you do something like this? How would you do something like this? There are different ways, and one of them is pull requests. Look at this. Say I have this temp1 repository, and someone from where? From Europe. Someone from Europe wants to improve my great code. It is great, but not that great, so they want to improve it. So what they will do, what is her name? Mary. Mary from London decided to improve my file. So she will do the following. She will clone in desktop. She's going to get the whole repository on her machine. She'll do some improvements in the text to test it, to like it or not to like it. Fine. If she will do something like this, she has it locally, but she has no right or rights to push it back into my repository. It's my repository. I don't want the whole world to mess with my code, right? So that's the problem. How can she give me something or offer me something or provide some changes? I think I have a slide on this. I want to show you on the slide if I have it. Yeah. So there are two ways of working with someone else's code. Again, Mary gets my code and she wants to do something with it. Two cases. Case number one, if she wants to take it from me, improve it, and never give it to me back, no problem. She can do clone. She can do clone and do whatever she wants with it. It's hers. But there is another case. If she wants to make a copy of my repository, not on her local disk, but on her GitHub account as well. Think about it. I have my GitHub version. She has under her, I have under Yakov Fain, this temp one. She wants to have under Mary on GitHub as well, the same exact copy, and be able to work with it and to make some changes to her repository under Mary. So that thing is called fork. If she will select fork, she will get exact copy on GitHub of my repository. If she will do simple clone, she will get a copy on her local disk. Let me show you this diagram, maybe it's easier. Say this is my repository on GitHub. This is my desktop local machine. I use Mary, let's say it's not Mary, it's Victor from London. Now, if Victor wants to create a copy on GitHub of my repository, he will do fork. He will do fork, which will create under his ID, under his account on GitHub, the same exact copy that I created. In my case, it's just index.html. Then he can clone and do pull push over here between his repository and his machine, local. Then he finally realized, yes, I did a fix, it's improvement, Yakov will like it definitely. So what he can do now, he has his repository with improved code on GitHub. I have my repository with original code on GitHub. So what he can do, he can send me a pull request. He would say, by doing this, he technically is saying, Yakov, I have a great stuff in here. I fixed a lot of things. Get it from me. Do a pull from me and merge it with your changes. At this point, I have a choice. Victor, I don't know who Victor is. Maybe he is some bum who doesn't even know how to program HTML. So I will look at it, at his pull request, and I will see what he suggests. And on GitHub, there is a way to exchange comments. I can comment, dear Victor, it's fine, but I'm not that happy with the code. Or he will say, okay, I will work on it. And then he will keep working in his pair local remote repository, then he'll say, okay, I'll fix it. He can do comments on the code, and then if I like the fix, I can commit his pull request. When I do that, then his great changes will be merged with my repository. So if you imagine, think about it, if you have not just a simple stupid index HTML like I showed you, but if you have a real open source project and you have multiple people who are committers, who are ready to submit their changes to improve your code, this is how the whole universe works. So they would fork your project, clone it locally, work on it, push back and forth, push pull on this vertical line, and then when they're ready, they will give me pull request, and this pull request will be approved, or should be approved, or maybe denied by the original owner of the repository. So if this would happen, when next time I open up my GitHub repository, over here I see pull request 0. But if Victor would be making all these changes in his repo, and he would initiate pull request on my repo, then I would see, oh, I have a pull request, 1 or 2, or maybe I don't know how many committers wants to do this. And to finalize the whole thing, URL for cloning, by the way, remember I told you, how do you know that what is the URL for cloning? It's right over here. You can copy it and use with Git. Use with Git when you configure the repositories. Next, there's a couple of other things that I want to mention, and we're going to be done with it. One of them is the changes. No, I'm not going to go through the changes. What I will do though, this is latest commit, by the way. Latest commit that was done, if you click on it, it'll show you what happened. See, it was originally hello from branch 2, and then I did hello from branch 2 to Git customers, right? It still tells you all the changes. Now, see this little plus sign? You can put comments in there. Yakov was trying to be funny. See, now I commented on this line. Of course, if this would be my communication between some of the committers to my project, they say, I want to do a pull request, and I would answer, no, you can't do this, or something like this. I would be commenting on that thing, which will allow or disallow the commits. So this is the conversation, to keep the conversation going. Now, there are other things that are, you can see over here on top, how many people forked your project. You can see how many people started your project. To start a project, it's a like on Facebook, so to speak. They like your work. And how many people watch this project. If somebody is interested to get the latest changes via email, as soon as somebody commits something in this temp 1, they want to be notified. They can watch the project. Let me show you maybe something better than this temp 1. For example, Farad Enterprise Webbook. The recent book that we finished writing, it was under Farad repository. It's the name of our company, right? And look at this. 50 people forked this project. This is entire text of the book, right? All the changes and everything. 50 people forked it already. Why? They want to have it locally. Then they probably cloned it. Now, in some cases, oh, by the way, there are pull requests. See that? Some people want to improve our book, right? So they went there. I didn't even pay attention to this, because, to be honest with you, this is a text of the book, and we write it for O'Reilly, and there are copy editors that will fix typos. I ask people, don't submit typos. It's not something that we will be fixing. O'Reilly editors will do that better than us. Anyway, so now issues. Somebody reported issues in the text of our book. Now let's see that. See, somebody is trying to say a few 404. I was actually responding to somebody with the comments. So people are trying to tell us that there are issues with the code maybe somewhere. I will take a look at it later. Now, so this pull request, they said that we fixed something, take it from us. Now, star people, see, 145 people put a star on this work. Obviously, they believe that it's great, which is nice. 42 people are watching this project. They want to know immediately if something is changing. They really work with a project which is our book. By the way, if you want to read it, go ahead, and we even created a website for it, enterprisewebbook.com. You can read all the content if you want. O'Reilly is nice enough to allow us to publish the code while we were writing it. It's under Creative Commons license, so read it for free, but never forget to put the right attribution, to put the names of the authors of this book. And we hope, of course, that when the book will be printed, which will happen in March or April of this year, 2014, you will run immediately into the closest bookstore and buy it, of course. Maybe you won't. All right, I hope you will. So in these slides, there are a couple of other pull requests, push requests, not push, of course. Some samples. Anyway, this is not a homework that you must do. Of course, most of you are just watching this video for pleasure while maybe sitting somewhere in the resort or maybe on a beach. But if somebody is committing or sending me the homeworks, as I explained in the beginning, then you will need to create your own repository on GitHub, and you will be sending me the URLs of your homeworks, which you will publish over there. That's enough, guys. That's enough. Oh, here's an additional tutorial I found for you. Check it out. It must be good if I put that link over there. Thank you very much. It was Yakov Fain with the lesson on introduction to working with Git and GitHub. Thank you very much for watching.